Okay, bismillahirrahmanirrahim. InsyaAllah hari ni kita sambung on ceramic part 2. Kalau part 1 ialah mengenai classification and their comparison, untuk part 2 kita akan bercerita mengenai properties of ceramic and their comparison. Okay, property pertama ialah mechanical properties. Okay, first we need to know that ceramics are more brittle than metal. Kenapa? It because of, kita tengok properties of the metal. Metallic have, okay, they are metallic bonds. Okay, so metals have metallic bonding. Allow the atom to slide past each other easily. Okay, so then dia akan lebih ductile. Okay, the sliding of raw atom result in slip, which allow the metal to deform plastically instead of fracture. So it become a ductile material. Sebab dia boleh slide with each other ke kiri atau ke kanan. So dia boleh menyebabkan benda tu ductile lah, mudah lentur. Meanwhile, kalau kita compare in term of ceramics, kalau metal ada metallic bonding, ceramics ialah ionic bonding. So there is a resistance to the sliding. Dia tak boleh nak slide. The raw cannot slide. Okay, the ceramic cannot plastically deform. Instead, dia akan fracture. Dia akan patah, which make it a brittle material. Okay, kalau kat sini saya dah tabulate ductile versus brittle. So, apa itu ductile? Ductile material can drawn into wires by stretching. Meanwhile, brittle will break, crack or snap easily. For ductile material, show deformation. And then for brittle materials do not show deformation. Dia tak boleh, bila ductile, bila kita tarik dia akan memanjang, for examples. Okay, tapi untuk brittle materials, once awak tarik, sebab dia tak ada properties untuk ductile tadi, then dia akan patah. So that's why they do not show the deformation. Meanwhile, ductile is affected by temperature. So, however, brittleness is affected by pressure or stress. Okay, tekanan. And then major example of ductile materials are metals, and then example for brittle materials include ceramics and glass. So kita tengok apabila ada graph of stress and strain yang dikenakan terhadap sesuatu material, merah boleh saya katakan ceramic sebab it's a brittle. So once you kenakan stress, semakin tinggi stress, okay, at one point dia akan snap ataupun patah. So ini yang akan berlaku. Meanwhile, sekiranya yang bawah ini, yang biru ini, kita anggarkan dia sebagai ductile materials. Apabila anda kenakan stress, semakin tinggi stress, strainnya akan makin memanjang, menyebabkan ni yang kita panggil strain ni yang dikatakan adalah deformation. Okay, tengok. Instead of patah, dia akan semakin panjang. Okay. However, until one point, dia akan tetap terputus ataupun patah juga. Tapi setelah mengalami deformation. Meanwhile, untuk brittle material, dia tak ada deformation. Ini dipanggil ductility test. Okay, ductility is the ability of a solid material to deform under tensile stress. So, dia akan a ductile material that can easily be stretched into wire when pulsed as shown in the figure. So, kita buat ductility ni macam inilah. Kita tarik dia, which is kita kenakan tensile stress ke atas sesuatu, and then kita temukan kepada satu endpoint di mana dia akan terputus lah. So, semakin tinggi tensile stress yang boleh dikenakan terhadap sesuatu material, semakin ductile lah sesuatu material itu. Okay, for example, awak boleh tengok baca contoh ni, sebab kalau you dah faham slide sebelum ni, sebab gambar rajah yang sama tetapi tiga keadaan berbeza. Ini adalah penerangannya. Okay, another things that we want to know in term of instead of brittles, sekarang kita tengok toughness. Toughness ni apa? Ability of a material to resist fracture. So, kita faham that ductile materials akan ada extensive plastic deformation. Ini phase ni kita panggil plastic deformation lah sebab ada perubahan and energy absorption ataupun toughness kita panggil before the fracture. However, brittle materials little plastic deformation and has low energy absorption before the fracture. Bukanlah dia tak ada langsung, dia ada tetapi sangat sedikit. Okay? Okay, here is the factors that affecting toughness. First is temperature. Second is strain rate, which is might considered from the static load ataupun dynamic load. So, next is the presence of stress concentrator. For example, Notch effect, a reduction in properties due to presence of stress concentration. Bila kita tambah stress concentration, dia akan tambahkan toughness. Okay, next is a strength to ductility ratio. Semakin tinggi strength to ductility ratio, semakin tough lah sesuatu material itu. Okay, so here is some examples. The value for fracture toughness ataupun kita panggil K1C dan unitnya ialah megapascals meters square root of 2. Okay. So then kalau kita tengok how the aluminium alloy, which is metals, have really big value for fracture toughness if compared with the ceramics. Okay, untuk for example soda lime glass hanyalah 0.7 hingga 0.8. And we got here is some composite and also polymers as we compare in between of the classification between metals, ceramics, polymers and composite. Okay, sekarang kita tengok definition on plastic deformation in ceramics. Okay, masa part 1 kita tahu yang ceramics ni ada dua, sama ada crystalline ceramics ataupun non-crystalline ceramics. So for crystalline ceramics, they have a regular crystalline structure, which is the slip ataupun dislocation motion occurs a little bit difficult. Okay, sebab ionic or covalent bond are really strong. Meanwhile, untuk non-crystalline ceramics, they have no regular crystalline structure, which there is no slip or dislocation occur. However, that material can deform by viscous flow. Okay, so bawah ni ada sources dan juga video untuk tengok how the non-crystalline ceramics act in the so-called in a viscosity of the non-crystalline ceramics. So sebenarnya slide ini slide daripada your senior, but there was a good information have been given. So nanti kalau ada semua, mostly each of the slide kat bawah tu dia letak reference, so then you can refer those reference. Okay. Okay, next kita tengok in term of crystalline and non-crystalline properties. So, kalau kita tengok yang hijau ini adalah crystalline and yang atas ini adalah glass. Glass adalah non-crystal lah sebab dia adalah amorphous solid. So, kalau kita tengok crystallize at melting temperature, kita ada satu kat sini dipanggil TM, which is have abrupt change in spec volume at TM. Maksudnya lepas pada dia cecah TM, melt ni, dia akan ada satu changes yang besar dalam volume dia. So kita tahu setiap material, bila dia berubah daripada solid kepada liquid, specific volume-nya akan bertambah. So that's how it's said here, have abrupt change in term of volume at the TM. Meanwhile, satu lagi kita compare antara glasses, and then glass do not crystallize, of course, sebab dia adalah amorphous materials. And then change in the slope in the spec of volume curve at glass transition temperature ataupun kita panggil sebagai TG. So kalau tengok daripada solid, dia dah nak jadi kepada liquid. So dia ada changes. Okay. Change in slope in spec specific volume dia berubah. Meanwhile kalau ni dia abrupt change lah, terus kepada sangat besar perubahannya daripada solid terus kepada liquid. Okay, and then for glasses it is transparent because no grain boundaries to scatter the light. Okay, next properties ialah viscosity. So first let's have a look. Viscosity ialah measure of non-crystalline glass or liquid resistant to deformation. Maksudnya kalau sesuatu glass, kita kenakan pressure ke kiri dan juga ke kanan untuk tengok how viscous there are. And then for high viscosity fluid resist the flow. Meanwhile, low viscosity fluids flow easily. So for example, kat sini, viscosity of water at room temperature ialah -3 poise. Unit untuk viscosity adalah poise. Meanwhile, kalau viscosity on the glass, tengok, greater than 10, the power of 16 poise. Dia sangat tinggi because it resists the flow. Meanwhile, kalau water, because of it is a low viscosity fluid with a really low value of it, so it flow easily. So unitnya macam ni. Dan of course lah kalau derivation kita ada force over area. Meanwhile, dV over dy, sebab kita kenakan kepada, kita letakkan satu force ditarik ke arah kiri for example. However, kita ada juga y and then v kat sini. Meanwhile, satu area lah yang dikenakan. This is how we determine the viscosity. Tapi suka untuk saya ingatkan, take note adalah high viscosity fluid is resist flow, meanwhile low viscosity fluid flow easily, dan unitnya adalah poise. Okay, so ni pun kita, your friend, semua topik sampai sini semua dah diterangkan sebenarnya, tapi mungkin diorang tak tekankan beberapa important point. So let's have a look. So importance of temperature. Understanding the relationship between temperature and viscosity is vital in determining the right melting and heat treatment regime in glass production and processing. So there are 5 standard temperature. Okay, di mana kalau tengok kita ada kat bawah, lepas melting point, kita ada working point, kita ada a softening point, kita ada annealing and then strain point. What it's mean by that? So for example, strain point is glass start to fracture and deform, which is yang paling atas lah. Meanwhile, kita ada annealing. Annealing is point when the glass may be heated after working to relieve. And then kita ada softening point. Okay, softening point is when glass can yield with a small amount of force. Okay, and then kita ada working point. Glass forming operation occurs in the between softening and working point. Di mana kat sini kita mula nak shape ataupun kita mula nak moldkan. Temperature di mana kita mula nak moldkan glass ikut apa yang kita nak. Okay, meanwhile the melting point, which is where the glass become fluid to be and considered as liquid. Okay, sebab tu bila dia liquid baru kita boleh moldkan. Lepas kita moldkan, and then kalau ni kita boleh, maksudnya dekat softening point ni, okay, which is glass can yield with a small amount of force. Kita boleh mula nak finalize produk kita. So kita ada annealing untuk compactkan, and then strain tu is a maximum temperature di mana kalau kita nak buat apa-apa, kita kena pastikan yang the glass cannot reach at that strain point, sebab lepas pada tu dia akan fracture. Okay, here is some examples of the temperature that we doing in the glass production and processing. Kita tengok untuk soda lime glass, the melting pointnya adalah around 10 points. Okay, meanwhile kalau working point dia adalah in range of, yang ni lah working range dia, sama ada 10 kuasa 4 sehingga 10 kuasa 8 lah. And then for the softening points, ialah temperature above, which glass cannot be handled without altering the dimension. Sebab dia ada a little bit, dia akan pecah juga. Sebab tu, cannot be handled without altering dimension. So, hanya sedikit sahaja. Kalau baca balik slide sebelum ni, in term of what is the softening point. And then kita ada strain point dan juga annealing point. And then you should be noted that viscosity decreases with temperature. The higher the temperature given, the viscous, the more viscous the materials, and many impurities will lower the T deform. Betul? Sebab semakin banyak kita tambah impurities dalam tu, kita akan kurangkan temperature deformation, and then glass decrease in volume after the cool down. Sebab tengok yang kita tengok tadi, glass yang awal-awal slide tadi yang cakap specific volume dia akan berubah. Okay, bila kita kenakan temperature, sebab daripada solid kepada glass, daripada solid for example kepada liquid, so basically the volume akan berubah, and then it should be in agreement when glass is decreased in volume after the cool down. Sebabnya daripada liquid dia nak jadi solid, so memang volumenya akan berkurang. Okay, here is some other importance of viscosity in glass making industry, di mana so as we know how to handle it, as macam kita tahu working temperature-nya, so then semakin viscous of course is hardly to shaping lah, so we need to exact viscosity for us to work with the glass. Okay, next properties ialah hardness. Kalau toughness berkait dengan fracture, hardness ni dia agak besar definition dia. Kenapa? Dia adalah mestilah merangkumi height resistant to deformation, and then height elastic modulus, and then dia mestilah height stiffness, so then it is hardness, and then next is height dimensional stability. So nanti kita tengok next slide, kenapakah hardness ni dikaitkan dengan all those four definition. Okay, so go for the definition. It is hardness implies a height resistant to deformation, and it's associated with the large modulus of elasticity. And then kalau kita masuk kepada metals, ceramics and most polymer, the deformation considered is plastic deformation of the surface. Okay, and then for elastomer and some polymers, hardness is defined at the resistant to elastic deformation. So itu yang dipanggil kepada hardness. And then technical ceramic components are therefore characterized by their stiffness and dimensional stability. So here ialah keempat faktornya. Resistant to deformation, modulus, and then stiffness and also dimensional stability. And because of that, hardness is affected from porosity in the surface, the grain size of the microstructure, and the effect of the grain boundary faces, di mana kita akan belajar next. Okay, hardness ini boleh dikawal dengan menggunakan cold work. Sebab ingat tak faktor-faktor hardness tadi, faktor effective hardness ialah grain, micropore structure. So then cold work involve the alteration of the size and shape of metals where plastic deformation occur. As we increase the cold work in time, which is in term of cooling rate, the hardness of the material akan increase. The metal become harder because it become more resistant to further deformation. So that's the definition of the hardness. So as we can see kat sini as a cooling rate increase, you boleh tengok the hardness also increase. That's how the cool work ataupun cooling rate ini influence ataupun play an important role towards the properties in terms of hardness. Okay, here's the video in terms of how cool work working. So kita tengok cool work we make the dislocation and tank and multiply, making the dislocation motion become more difficult. Okay, it become more resistant to further deformation, making the material harder. So tengok bila kita buat cool work, so dia menyusun dengan lebih kemas. Okay, will make the dislocation entangle. So dia tak ada dislocation anymore, and then it become more resistant to further deformation, which making the material harder. Okay, another factor that can increase hardness ialah internal strength, betul? So internal strength ni can be controlled by using annealing process. So what is the annealing process? Annealing process ialah process where is the material is heated above the recrystallization temperature of the sample and then cool down. The main purpose is to improve the cool work properties by increasing ductility and retaining most of the hardness. Annealing will reduce the internal strain and reduce dislocation density. And then there are 3 steps involved with annealing. So boleh tengok graph ini. First ialah recovery, and then kita buat recrystallization. Barulah akan ada grain growth. So ni adalah graph ataupun step yang akan involve when you are using annealing, and then this is how shaping of the grain terhasil after we do the annealing process. So annealing process adalah dikaitkan dengan recrystallization. Kita nak membentuk semula grain of the material itu. So recrystalline change the microstructure by heating the material to the temperature above of the crystallization, and then from the graph you can see that temperature are used to control the final grain to achieve the desired mechanical properties. So kalau kita tengok sebelum ni, okay, sebelum ini adalah yang asal. Kemudian bila ada recrystallization, kita akan membentuk new grain, and then finally grain growth phases yang di belakang ini. Okay, so this is how kita cuba gunakan annealing process, dan kita tengok at temperature, which temperature that we want to stop the annealing process, because the temperature ataupun grain ni akan proportionally bergerak dengan temperature. So we need to know what temperature that we are using to achieve the desired mechanical properties for the end use there. Okay. Okay, next is elastic modulus. The term elastic modulus akan refer kepada relative stiffness ataupun rigidity. A stiff material, benda yang stiff, will have high elasticity component, whereas the flexible material will have a low elasticity module. So kita tengok stiff material ni sebenarnya dia ada high elastic component dalam tu, whereas the flexible material dia ada low elasticity module on it. So unitnya adalah gigapascal, which is kalau kat bawah ni kita boleh tengok lah di mana silicon carbide, silicon nitride, okay, have high elastic modulus, which give a huge value for the hardness. Okay, so that's how it show in the graph. Okay, now dia masuk kepada topik yang kita pernah jumpa pun, tapi your friend didn't even explain it details. So it is to measure the elastic modulus. So kita akan ada 3 point bending test ataupun 4 point lah, but basically we do the 3 point bend test So first you need to know the formula that been involved, which is it depend in term of materials kita might having the cross section of the rectangle ataupun circles depending on the material used. So kalau circle ni biasanya wire, so kalau wire kita guna radius because it circles, and then kalau the material in the term of the rectangular, kita tengok ni lah jarak, panjang dan lebar dia. Okay, so then kita kena tahu satu lagi, apabila satu force dikenakan, okay, since it's 3 point, which is 3 point ni refer kepada dua kiri dan kanan yang akan menyokong bersama satu force daripada atas. That's why we call it as a 3 point. So point tersebut mestilah half daripada jarak antara support kiri dan kanan. This is how, kalau formula, kalau soalan suruh kita derive, so you should know to draw this figure exactly how it is. So half of the length, and then force dikenakan terhadap tengah-tengah sampel tersebut. Okay, so we know that force over deflection, which is the slope, ialah F over deflection lah. So bila kita kira balik untuk tengok elastic modulus, this is how it goes for the N formula dia. Bergantung kepada material yang kita ada, sama ada dia adalah rectangular ataupun circle. First, of course, the concept mestilah force over deflection. Okay, then kita mesti times dengan material yang kita gunakan. First, we need to know the length of the materials. And then, kalau material itu kita gunakan rectangle, should be 4 BD kuasa 3. Ni pun kuasa 3. Okay, meanwhile, kalau kita gunakan circle cross section, this is how the formula goes. Ingat, at least you know how to substitute the value. Okay, kat mana? Okay, dari rumus yang sama juga akan boleh juga kita determine the flexural strength ataupun kita panggil juga sebagai flexural modulus. So menggunakan the same theory daripada yang modulus, kita boleh tentukan nilai deflection, di mana formulanya seperti ini, FL force length kuasa 3 dengan per 48I dengan E. I ini bergantung kepada still which material that you are using. If it rectangular, so go for this value ataupun formula. Meanwhile, if there are circular, so this is pi r4 over 4. So that's how it goes. Okay, this is just the theory on it. And then it should be noted yang the higher the flexural modulus, the more stiffer the material and the lower the deflection. Okay, so apa itu flexural modulus? Ialah the ability of material to bend. It is measure of a material stiffness or resistance to bend when force is applied perpendicular to the long edge of sample known as 3-point bend test. This is common yang anda akan jumpa lah. Okay, untuk flexural test, biasalah by definition dia adalah which a root specimen have either a circular or rectangular cross section is bent until fracture using 3-point or 4-point loading technique. Dia adalah teknik ataupun test lah. And then untuk flexural strength, dia adalah the stress at fracture using flexural test. So stress maksudnya loaded tu is computed from either specimen thickness ataupun the bending moment. So stress decrease with increasing of specimen thickness, of course. And then stress increase if the bending moment increase. The moment of inertia of the cross section, ni lah I ni. So bergantung kepada material yang kita gunakan. Okay ya. So here is a figure in terms of 3-point test and 4-point flexural test. So basically all the formula that we are discussed until now is a 3-point, okay, because of in term of length dan sebagainya. So it is just like a figure that they are also called as a 4-point flexural test, di mana dia punya formula is berbeza daripada yang kita guna for the past 2 or 3 slides. And then this is the real figure ataupun real sample yang dikenakan 3-point bending test. So kita ada 2 support and then 1 pressure yang menekan ke bawah dan length dikira daripada sini untuk membentuk the formula. So here is some mechanical properties of the ceramic in term of flexural strength dan juga modulus of elasticity. So for example, kita boleh tengoklah soda lime have the lowest flexural strength. So sebab dia once you kenakan pressure di tengah ni, dia memang akan terus patah. Okay, and then dia juga tidak elastik sebab once you buat test, you tarik kiri dan kanannya ataupun you kenakan satu pressure, dia memang akan terus putus. Meanwhile, kalau kita tengok silicon nitride, which is a ceramics, dia akan have the high flexural strength dan juga modulus of elasticity. Okay, here is some examples soalan yang biasanya kita akan bagilah. So kalau kita tengok, a 3-point bending test is performed on alumina. Circle cross section of radius 3.5 mm. The specimen fracture at the load 950 when the support point are 50 mm. Okay, consider a square sample of the same material with the cross section of 12 mm times 40, 12 on each edge, sorry. If the support points are 40 mm apart, so at what load is the sample will be fracture. So sekarang kita tengok berapakah, sebab dia kata consider sampel yang sama. Okay, so kalau kita tengok cross section circular and cross section in term of square, dia nak tahu berapakah force. Kalau force yang atas ialah 950 N Newton, so what force that will the square sample ni akan patah. Okay, untuk solutionnya, first kita mesti determine the flexural strength sebab dia menggunakan material yang sama. Okay, so just go flexural strength, which is kita ubah balik, kita ada force which is 950, kita ada length and then kita ada nilai R. So kita tahu sekarang nilai flexural strength of the material ialah 3.5 times 10 to the power of 8 pascals. And then daripada dapatnya nilai ni, kita masuk balik kepada formula untuk modulus again. So ini adalah formula yang kita ada, derive daripada still a flexural strength yang sama. So we do have the value for the flexural strength. What we want now is the force. Betul? So, since we need to determine the force, here is the new formula. So, then it's go for 2BD flexural strength or forces over 3L. So, masukkan value yang terlibat. So, you got the final answer ialah 10,170 Newton instead of 950. Walaupun material yang sama, somehow atas dia menggunakan circle with the radius of 3.5. Meanwhile, yang di bawah dia gunakan sigma dengan 12. Betul? Millimeter juga. So, because of thickness yang lagi tebal, that's why force yang boleh dikenakan lebih tinggi compared to the specimen in a circular tadi. Okay, ya. So, here is summary in term of 3-point band test. So, goal, ingat macam mana sekiranya soalan disuruh derive, you mesti tahu cara lukis figure ini. Sebab daripada figure ini terbentuk the formula flexural strength dan Young modulus. Okay, remember? Okay, next is about the stress strain behavior graph. So kita boleh tengok ceramics, and then for hard and brittle is again is a ceramic, and then here is the link for the ceramic. So it shows that ceramic is a hard and brittle materials. Okay, sebab stress boleh dikenakan, semakin tinggi stress, dia boleh menahan, tapi strain dia, kalau kita strainkan dia, dia takkan dapat the strain compared to other material lah. Okay, and then for ceramic, there is a little strain for high stress. Okay, and then the fracture of the ceramics is sudden with little or no plastic deformation. Maksudnya, kalau kita ambil contoh untuk polymers for examples. Okay, apabila kita kenakan stress, okay, so basically polymers have a really can form a plastic deformation. Meanwhile, untuk ceramics, tengok dia takkan wujud maksudnya in term of ductility dia tak ada, sebab the higher the ductility, the bigger the performance in term of plastic deformation. However, untuk ceramic, since it is brittle, okay, so because of that, there is no plastic deformation ataupun the fracture is sudden. Okay, next is strength. So it should be noted that ceramics have greater strength compared to metals. Okay, however, ceramic have a limitation, and the main limitation of the ceramics, because it having a brittle fracture with little or no plastic deformation, and this is due to low energy absorption before the fracture. Ceramic are catastrophic, meaning that the brittle fracture occur without warning. So that's how that is the limitation of the ceramics. Okay, next is the strength ataupun factor that influence the strength of the ceramics. The first one is the material composition. The properties are intimately related to the certain type of chemical bonding, which is ionic bond and or covalent bonding. The second one is the manufacturing process, which is soaking, firing temperature, also flux content. The third one is the production condition, which is increasing in porosity while lowering the strength. And the last one is the grain size of initial material and the additive. So yang ni penting sikit sebab grain size the finer the grain size ceramic, smaller flaw size at the boundaries, hence the stronger than larger grain size. Okay, ingat smaller or finer grain size ceramics is stronger than the larger grain size. So kita tengok nanti antara faktor yang boleh produce the finer grain size of ceramics. Okay, to produce the finer grain size, it should be altered during a sintering process. Okay, how the sintering process work? When you have the material, kita akan moldkan dia, membentuk dia, then it will undergo the sintering process, where the molded object will go for the firing, and then the fired object. Tengok how daripada ada slit ataupun pores yang ni, bila kita panaskan dia, dia akan mengembang, and then kita akan panaskan lagi to produce the final grain of the ceramics, and then it go for machining, which is some ada cutting dan sebagainya before we produce as a end product. Okay, here is the details in terms of sintering process. The first one is sintering is a process by which powder compact is transformed to a strong dense ceramic upon heating at a high temperature. Okay, and then it's performed in a furnace called kiln. And then during this process, advanced ceramic shrink and experience reduction in porosity, ataupun kita panggil shrinkage. And then after that, it will eliminate most of the pores in the ceramic particles and compress residual pores, bringing grain and improve the binding among the grains. So kita tengok daripada macam gambar ajar sebelum ini, daripada kita ada pores antara slit ni, and then once kita heating, okay, dia akan mengembang, which is dia akan shrinkkan pores yang ada. Kemudian dia akan membentuk final grain. Okay. Baca kat bawah. During firing, the space between particles shrink until the particles fuse together, resulting in fired objects that are very dense and hard. So sebab itulah dia akan lebih bertambah strength after the sintering process. Here is the details in terms of sintering stage, which is the initial stage allows ceramic particles touch one another, thus each gap between the particles become a pore. Kalau kita tengok ni yang asalnya, dia ada pore dekat tengah. After that, the intermediate stage, bila kita panaskan, the first heating, is the size of the grain enlarged. Okay, grain tadi ni dia akan membesar, result in significant increase in strength and pores become smaller. Pores tadi yang besar tadi, they become smaller. Okay, with the increase of sintering time. And then after that, the final stage is size of pore small, improve the binding among the grain. So, bila this is after sintering, and then this is before sintering. Okay, kita boleh tengok perbezaan dia. Sebab tu, after the sintering process, the material ataupun the ceramics become stronger. Okay, next is a density ataupun specific gravity. Rumusnya kita tahulah density ialah mass over volume. Okay, so then here is technical ceramic are significantly lighter than the high strength metals, typically half of the weight comparable to the metal part. And the density of the technical ceramic lies between 20 or 70% of the density of steel, which is dia lebih ringan lah. This has significant effect in terms of properties of ceramic. Sebab tu, kita banyak gunakan ceramics compared to metal. Okay, because of the density juga, dia lebih ringan. Only the lightest advanced ceramic will be specifically used in industry. For example, silicon nitride for the bearings, and carbide in the space industry for structural part reflector nozzles, or etc. Here is some comparison in terms of density. Dan kalau kita tengok ceramic itself, okay, here is the samples, okay, compared to metals. Okay, here is another samples of the ceramic. We can say that ceramic are intermediate in density between the polymers. Polymers dia sangat rendah, and metals is too higher. Okay, and then non-crystalline metals are less dense compared to crystal. Of course, sebab metal sangat dense. So kalau kita tengok silicon nitride is non-crystalline materials. Okay, meanwhile silicate ceramics is a crystalline one. So we can say that dia adalah lebih lesser in term of dense, and composition with several allotrope such as silica have a minor difference in term of density. Okay, next is porosity. So kalau kita bercakap pasal porosity, kita boleh tengok gambar lah how the porous material is called. And then ceramics material are usually ionic or covalent bonded material and can be crystalline or amorphous. And then because this material tend to be porous, the pores and other microscopic impression act as a stress concentrator, decreasing the toughness further and reducing the tensile strength. So kalau kita tengok, how does porosity affect the strength? Okay, the higher the porosity, the lower the strength, because of the fracture energy decreases as the porosity increases. In terms of porosity, technical ceramic materials have no open porosity, and then porosity can be generated through an appropriate selection of raw materials, the manufacturing process, and in some cases, through the use of the additive. This allows closed and open pores to be created with the size of few nanometer or micrometer. So here's a figure. So kita tengok in terms of silicon dioxide, silicon ceramic form obtained from the pre-ceramic polymer. Bila dia berubah, change amount of porosity. Okay, sekiranya dia semakin porous, the elastic modulus semakin berkurang. So kita boleh tengok the strength dia akan berkurang sekiranya porosity is increase. However, kita tengoklah depends on the end use of the ceramic itself. Mungkin kita nak material yang porous. Okay, sebab material yang porous dia lebih less dense compare kepada material yang compact. Dia akan lebih dense. Okay, so now it's about the thermal properties. So kita ada including thermal, satu lagi kita ada electrical, dan lastly is the optical. So start with the thermal properties, definition and effect. Okay, for the thermal properties of ceramics, there should be a few definition on it. For example, in terms of heat capacity, thermal expansion coefficient, thermal conductivity, and also thermal shock resistant. So boleh baca for each of the definition, then kita boleh proceed. So for the thermal expansion coefficient, okay, when the material are heated, their size and volume increase in a small increment, of course, material, which is the expansion values are vary depending on the material that being heated, and the coefficient of the thermal expansion indicate that how much a material expand for 1 degree Celsius rise in the temperature. And it should be noted yang fine ceramic, also known as an advanced ceramic, have low coefficient, which is less than half of those stainless steel. Kalau kita tengok metal, bila kita panaskan, it have a larger thermal expansion coefficient. Meanwhile, kalau ceramic, tengok, it is little thermal expansion. So it's good to use ceramics, of course, when you are dealing with the high temperature materials ataupun high temperature process. For the thermal expansion coefficient, it depends on the bond strength between the atoms that make up the materials. Strong bonding, for example, from silicon carbide, silicon nitride, and diamond have really low thermal expansion. Meanwhile, weak bonding, although it is the ionic bonding, for example, in the stainless steel, it have higher thermal expansion coefficient in comparison to the fine ceramics ataupun advanced ceramics. So kita tengok zirconia, alumina, silicon carbide, and silicon nitride. Okay, dia sangat kecil if we compare kepada stainless steel. Okay, next is a thermal conductivity. So go kepada definition. Thermal conductivity is the property that measure how well heat is transmitted through a material. Okay, among advanced ceramics, some material possess really high level of conductivity and transfer heat really well, while other possesses a low level of conductivity and transfer less heat. Okay, if you are compared to the carbon steel, okay, it is, kita tahu dia adalah good thermal conductivity lah metals ni if we compare to the non-metals. However, we should go for the advanced ceramics. We can see that aluminium nitride have the highest thermal conductivity, and also silicon carbide, okay, as we compare kepada metal. So that's how the advanced ceramic works. Okay, thanks to your senior, this is really good figure untuk tunjukkan what is thermal conductivity. Kita boleh tengok dekat bawah. So high thermal conductivity, once you heated, dia transfer the heat really well. Meanwhile, untuk yang low thermal conductivity, tengok, dia just half of the material, so it is don't even transfer it. So then have a look that aluminum nitride and silicon carbide transfer heat particularly really well. And then all these things you boleh baca lah. For example, zirconia block heat effectively and its coefficient of thermal conductivity is low, which is 1/10 of stainless steel. Sebab tu, untuk kiln walls, okay, yang kiln tu yang furnace yang kita gunakan untuk sintering process tu, which are exposed to the high temperature, it is used, zirconia is used compared to stainless steel. The last one for the thermal is a thermal shock resistant. Thermal shock resistant is the property of a material that makes it resistant to a sudden or rapid temperature change. Materials that having high thermal shock resistance are able to withstand the wide temperature variation. Some ceramic material have a very high resistance to thermal shock, despite it is ductile. For example, fused silica and also aluminium titanate. And result of rapid cooling and thermal stress, dia akan menyebabkan crack and consequent failure. So the thermal stress depending on geometrical boundary condition, thermal boundary condition, and also physical parameters in terms of elastic and also strength. Okay, here the second last before the optical, we will talk about the electrical properties, which is dielectric and conductivity. Okay, here is some electrical properties of ceramic. Ceramics are dielectric, and then it's meaning that materials is a poor conductor of electrical, however, it supports the electrostatic field. So ceramic product often used as an electrical insulator, such as spark plugs and protective parts. And these products are primarily used in the sectors such as automotive, marine, transportation, aerospace, dan juga electricity distribution. For example, as a capacitor, resistor, dan juga inductor. So there are two factors that affect the electrical properties. Okay, the first one is a frequency, and the second one is a temperature. For frequency, charges transport mechanism are frequency dependent, which as frequency increases, the current tends to flow along the surface of the conductor. And then for the temperature, activation energy can be achieved through the thermal energy. Charge migration needs activation energy, and higher temperature will cause immobile charges to become mobile. Okay, superconducting properties. Most ceramics have very low electrical conductivity. However, there are ceramics that possess superconductivity. Okay, as we know that conductivity is depending on the temperature. However, for the superconductors, there are materials that conduct electricity with no resistance. For example, material ini that may superconducting at temperature as high as 138 Kelvin. As we know that as the higher temperature for the material, kita akan lost the conductivity. However, the superconductor, dia boleh conduct with no resistance. And most superconductors have critical temperature up to 30 K, which is TC is a temperature below which material is superconducting. So kalau tengok kita ada notes kat bawah ni yang you boleh refer. Okay, here is the examples more. Some material, when they are cool below certain temperature, their resistivity get abolished, which means they exhibit the infinite conductivity. Maksudnya they have no conductivity level lah. So this property of phenomenon of infinite conductivity in material is called superconductivity. And resistance is the hindrance of to the flow of the electrons in material. Resistance discourage the flow of the electrons, and when the temperature goes up, the resistance also goes up. Tengok perbezaan antara non-superconductor and superconductor. Dia ada satu critical temperature, which is without resistance, dia memang boleh conducts. Okay, that's what it means. For example, here lah, kita boleh tengok that superconducting state, which is without infinite resistance, dia still have a conductivity properties. Okay, here is some general comparison of material properties, which is kita ada density, kita ada bending strength, kita ada bending strength at temperature, and also elastic modulus dan juga fracture toughness. So kita boleh tengok beberapa comparison lah, compare to mild steel or cast iron, also porcelain, which is traditional ceramics, okay, and silicon nitride is advanced ceramics. Kita boleh tengok how perbezaan dia. Also, here is some properties lagi comparison antara tiga, which is ceramics, metals dan juga polymer. Okay, table ni agak penting juga In term of hardness, ceramics are very high, okay, compared to metals. However, polymer is very low. Dan the rest lah you boleh tengok saya tak bercadang untuk ulang setiap satu, sebabnya actually is about yang kita dah pernah belajar pun. So in term, cuma table ni simplified lah. For example, ductility, kita tahu ceramics are really low inductivity, and then metals is high, and also polymer is ductile juga. However, in term of corrosion resistant, ceramics are really high, okay, compared to metals, okay, dan juga polymer, okay. Sama juga in term of density, ceramics is low and metal is high density. However, polymer is a very low. So that's how it works, okay. Okay, the next one ataupun the final one is a optical properties. So optical properties of ceramic ataupun optical properties ni, we always talking about the refraction. Refraction happen when a light transmit from one medium to another medium, and normal line is perpendicular to the boundary line. So basically, if we talking about refraction, kita akan ada satu incident ray, and then you akan nampak dia bukannya tercapah begini, tapi dia akan ada satu ray yang kat bawah, di mana ray A ini, objek ini, dia akan melalui satu titik, kemudian be refracted. So itu adalah refraction yang kita panggil. Okay, here is how to calculate the refractive index, which is N, based on Snell's law. You dah belajar dah ni. So this is the recap where N equal to C over V, where N is a refractive index, C is the speed of light, and V is the speed of light in that material. So then because of that, barulah kita jumpa apakah nilai refractive index. Daripada Snell's law ni lah kita wujudkan this formula. Okay, here's is the important part where kenapa kita perlu tahu refractive index ni for the ceramic. For example, kat sini refractive index of selected ceramic, kita boleh tengok the value. Because of the higher the refractive index, the slower the light travel. Betul? So, kalau you tengok daripada dense, yang more dense kepada less than, dia akan mencapah lebih banyak. Kat sini and sini. Okay. Theta A, theta B. Okay. Which indicate that material is more dense. Okay. The higher, ingat konsepnya, the higher the refractive index, the slower the light travel, of course. Which indicate that material is more dense. Okay, here is another optical properties of the glasses. So glasses is transparent, of course, because of the photon of visible light travel through the glass instead of being absorbed or reflect. Sebab tu kita tak nampak colored. Okay, the transparency of the glass depend on the composition of the element used in the glass, and radiation of some wavelength can cause the glass molecule to vibrate, making the glass opaque. So here is the perbezaan antara frosted glass ataupun opaque compared to the regular glass. So details you boleh tengok kat video ni, why glass is transparent. Okay, next is the absorption. Most ceramics are colorless, and then colored ceramic can be produced by adding transition metal during the production of the ceramic. For example, among the colors of the material yang kita boleh gunakan, of course kita gunakan transition metal, sebab different oxidation number we produce the different color. So kita tengok vanadium, for example, for the purple one we can use +2, and then green one +3, blue one +4, and then untuk +5 oxidation number will be the yellow color. So that's how we add the color for the ceramics. With the addition of those color, here is goes from the colorless ceramics into various application. Okay, with the addition of the metal ion tadi tu. So ini adalah final productnya. So I think that's all for today. So that's the end of the lecture for the glass and ceramics topic ataupun glass and ceramic class for this semester. So I will say thank you first, and a gently reminder about the final exam. Okay, final exam as we say, dia tak masuk chapter on the hazard anymore. It should be start from the glass chapter, and then plus ceramics. So untuk glass, it is important for you to remember the definition, and then kalau glass, kalau ceramics, kita ada macam-macam methods kan, slip casting, extrusion dan sebagainya. Kalau glass, the important part ialah float glass formation. You boleh tengok macam mana. Remind balik sebab saya tak repeat semula dah in term of glass So just some reminder on it. And then kalau ceramic ni, kita tengoklah the calculation dan sebagainya. This is final exam. Just remember, do some revision. So we just have like 3 chapter, which is glass, ceramic part 1 and ceramic part 2. So remember on it. Good luck for your final exam. Buat yang terbaik insyaAllah. Assalamualaikum.